All right, so last time we created our P over Q list, and we're going to be using that to try to factor this polynomial. All right, so let's try plugging in 1 for x up here. So I've got 1 store for x. All right, and then I'm going to type in this entire expression. All right, entire thing. Now, thankfully, I've already did that up here earlier. All right, so I've got the whole expression in there, and I'm plugging in 1 for it. All right, gives me negative 180, so it does not work. All right, let's try negative 1, store to x. All right, and then we'll plug in that exact same expression, and we do not get 0, unfortunately. Okay, so that means 1 will not work ever, no matter what we do. So let's try 2. 2 store for x. All right, and then we'll evaluate this. Okay. Oh, and it does give us 0, and that's what we wanted. All right. Because it gave us 0, that means that x minus 2 is one of our factors. Try to clear some of this up here. No, it must be a glare. Oh. I guess I could scoot the calculator up, couldn't I? Yeah, that's what it does. All right, so because 2 gave us a 0, that means that x minus 2 is one of our factors. So I'm going to write x minus 2 at the bottom of my page here. All right, that's one of my factors. So I'm going to take this original polynomial and I'm going to divide it by x minus 2. So using synthetic division here, we're going to have 6, 23, negative 4, negative 78, negative 83, negative 56, and positive 12. Okay, let's try this out. We're dividing by x minus 2, so we need a 2 on the outside here. Bring down our 6. 2 times 6 is 12. Add those, you get 35. 2 times 35 is 70. Add those, and you're going to get 66. 2 times 66 is 132. Add those, and you're going to get 22 plus 32 is 54. And then 2 times 54 is 108. Add those, and you'll get 17 plus 8, so 25. 2 times 25 is 50. Add those, and you'll get negative 6. 2 times negative 6 is negative 12. Add those, and you get 0. Wow. So this is our new polynomial. All right. Now, I already know 1 doesn't work when I plug in 1 for all this. Oh, by the way, I'm not going to actually write out 6x to the 5th power plus 35x to the 4th power. I'm just going to leave it like this. And I'm going to use my synthetic division later based off of this. So let's type in my new expression here into the calculator. So we've got 6x to the 5th plus 35x to the 4th, bell ringing, 66x to the 3rd, 54x squared plus 25x minus 6. Right there. Okay. Now, if I press enter, it's going to be testing whether 2 will work. And I want to do that anyway, right? Because I want to find out whether 2 could possibly be a double root. All right, so that means that 2 is not a double root. All right. So I've done, let's see here. I've already done positive 2. I can do negative 2. Negative 2 store to x. And then I'll type that into my new one, all right? And that gives me 0. All right, cool. All right, so if negative 2 is an x-intercept, that means that x plus 2 is a factor. Right? So I'm going to be dividing my new polynomial by x plus 2. Right? I'm going to divide that by x plus 2. So I've already got my coefficients here. I'm just going to do my synthetic division again. But I'm dividing by x plus 2, so that'll be a negative 2 on the outside. All right, let's go here. Drop down my 6. Negative 2 times 6 is negative 12. Add those and you'll get 23. Negative 2 times 23 is negative 46. Add those and you'll get 20. Multiply those and you get negative 40. Add those and you'll get 14. Multiply those and you get negative 28. Add those and you get negative 3. Multiply those and you get 6. And that is our remainder, 0. That's what we wanted. So this will be my new polynomial. Okay, let's type that in. We got 6x to the 4th power this time. All right, plus 23x to the 3rd, 20x squared, plus 14x minus 3. All right, so if I press enter, it's going to be testing negative 2 again. Remember, that was the one that we had stored in for x right now. Let's try it again. We'll see if negative 2 is a double root. It is not. All right, so let's go back here. So I know that 2 didn't work earlier, and I just found out that negative 2 doesn't work. So 2 and negative 2 are off my list, my P over Q list. Okay, let's try 3. 3 stored x, and then we'll evaluate that up here. Nope. How about negative 3? Evaluate that up there. Oh, it did give us 0. Wow. All right, so negative 3 works. That means that x plus 3 must be a factor. All right, so I've got x plus 3. All right, so I'm going to be dividing this new polynomial by x plus 3, which means negative 3 needs to go on the outside. All right, so bring down my 6. We've got 6. Negative 3 times 6 is negative 18. Add those and you get 5. Multiply those, you get negative 15. Add those, you get 5. Multiply those, you get negative 15. Add those and you'll get negative 1. Multiply those and you'll get 3. Remainder, 0. All right. So this is my new polynomial. Let me type that in. Ooh, excuse me. All right, so I've got 6x to the 3rd, 2nd, 1, 0. Okay, to the 3rd power plus 5x squared plus 5x minus 1. Now this is going to check negative 3 again, all right, in case it was a double root. It is not. All right, so that means that 3 and negative 3 are off of my list. All right, so those do not work. All right, so let's try the rest of the whole numbers here. We got 4, 6, and 12 to try. All right, so I got 4 stored x, and then we'll evaluate that again. No, negative 4 stored x. Evaluate that again. So 4 does not work at all. It will never work, so I can take it off my list. 6 store to x. Evaluate that again. Does not work. Negative 6 store to x. Evaluate that again. Nope. So that means 6 will never work. All right, now I'll try 12. Fat chance, but I'll try it anyway. Does not work. Negative 12. Let me try that one. And no. All right, so that means our last rational zeros, if they exist, are going to be fractions. So I'm going to start at the beginning of my list, 1/2, and go from there. I'm going to stop here for the video though.